Okay, I think we'll go ahead and get started. So welcome everyone to this session on SIG Apps, Kubernetes SIG Apps. My name is Adnan Abdulhussein, and I make up a third of the SIG Apps chairs. So along with Matt Farina from Samsung, who is at KubeCon, but I don't think he could make it to this session this morning. But he is around, and he will be at the SIG Apps deep dive later on as well. And I think a couple more of us will be. And then Kenneth Owens as well from Google, who unfortunately can't make it, or I guess not really unfortunately, because he's caring for his newborn. So just a show of hands, how many people have been to a SIG Apps intro or deep dive previous KubeCons? Cool, just one, or a couple actually. How many people have been to SIG Apps meetings before? Okay, cool. Yeah, so it sounds like there's a few people who know about SIG Apps. How many people, is it their first time that they're checking out SIG Apps? Cool, so that's quite a few people, that's great. So hopefully I won't bore a lot of you who kind of already know what SIG Apps is all about, but I'll give a brief kind of introduction to SIG Apps, and I'll give an update to kind of what we've covered since the last KubeCon and some of the achievements that we've made. And then I'll also point out some other things that are going on, and like the deep dive that's going to happen later this week, and also give you some pointers on how you can get more involved. So SIG Apps is basically a place to go and discuss how people are deploying and defining applications in Kubernetes. And our kind of core demographic is the kind of application developer or the application operator. So we kind of center around their experience of using Kubernetes. So this means two things. We own code in both core and external. In core, we take care of the Workloads API. So I'll go through this in a little bit, but these are the kind of APIs that you're familiar with deployments and stateful sets and daemon sets and all that good stuff. But we also own some tools that are used to kind of help define and deploy applications. So things like Compose with a K, which takes your Docker Compose files and helps you migrate that onto Kubernetes. And then some other tools that are working on improving the interoperability between other deployment tools like Helm and KSonnet and other tools like that, and making it easier to work within them. And that's the application CRD and controller, which I'll go over as well in a little bit. But that's kind of the code that we own right now. And then outside of that, we also kind of just have a discussion platform. So our meetings are mostly discussion-based, I would say. And we're trying to listen to users and, again, the application developers and operators, and trying to hear how they're using Kubernetes and drive some of their feedback into developing features for Kubernetes, and also developing tools in the ecosystem that help solve some problems that they might have. So the idea is to kind of represent those needs and facilitate communication between users of Kubernetes, operators of Kubernetes, and contributors of Kubernetes as well. So in our meetings, we'll have the application developers and operators, but we'll also have core contributors to Kubernetes there, able to give answers on what's going on with daemon set or what's going on with stateful set, and you'll be able to go and get those questions answered there. So I mentioned the meetings. We have meetings, 1-hour meetings at 9 a.m. Pacific time every Monday. We'll start with an introduction, and if there are any announcements that need to be made, like if there's a survey going on, we'll announce it there. Sometimes we'll have a quick like verbal survey, to find out how many people are going to KubeCon from the group or things like that. And then we'll typically have some demos. So typically 1 or 2 demos, like 10-minute demos on new projects in the ecosystem or updates to existing projects. And then there'll be scheduled discussion topics. And right now we're kind of alternating between discussions around the Workloads API. And then the other week we'll have discussions around developer tooling. And again, in the ecosystem, what kind of tools are going on, tools are being developed out there, things like Scaffold and Draft and Helm and stuff like that have been discussed during those topics quite a lot. And then if there's time for it, sometimes there is, sometimes there isn't, we'll move on to open discussion. And really, that's kind of just time for anyone to bring up any questions that they might have, or point out any issues or GitHub issues or PRs that they want to be looked at. So the Workloads API, hopefully you're all kind of familiar with this, but if you aren't, I'll kind of go through this really quickly. So deployment, kind of probably the most used workload API, and basically allows you to manage your pods and scale them out and apply running updates and rollback. An implementation detail of the deployment is the replica set, and typically you wouldn't use this directly. Deployment uses this as a way to scale out pods, but you wouldn't typically use this directly. The deployment would go and create and manage the replica set for you, and that's really to kind of separate the concerns of both the deployment and the replica set. So the replica set controller is really good at making sure that there are n number of pods running, and then the deployment can use that to then apply things like rolling updates and rollbacks. Then there's the replication controller, which is a legacy API, and really you should be moving to deployment, and so you shouldn't really be using that anymore. It's still in the core v1 API as legacy. And then if you're running stateful workloads, so things like databases, you probably want to use stateful set. And what you get with stateful set is you have each pod will have a static ID, so a unique ID for it, and then they'll also get their own volume. And depending on the mechanism that the strategy that you use to deploy them, by default, stateful set will roll out one pod at a time. But there's a burstable mode as well to just deploy all pods at the same time. And then in the batch API, we also own jobs and cron jobs. So jobs are basically used, again, similar to deployments, a way to run a set of pods at a time. But the main difference is that those pods will run to completion. So it's really good for doing any sort of batch processing that you might need, and something that doesn't need to be constantly running. And then jobs can also report status on whether those jobs succeeded or failed, and there's retry mechanisms and things like that. And then cron job allows you to schedule jobs to run at specified intervals, so similar to cron. And then finally, there's daemon set, and daemon set is used to run a certain number of pods, to schedule pods on every single node in the cluster. And this is useful for things like network add-ons. So I think things like we would use this to make sure that there's a pod on every single node. You'll notice that all of these workloads have I don't know if you can see my mouse here, but they all have a group and a version. So you probably have seen this in other when you're looking through the API in Kubernetes, but there's usually an API group and then a version for that particular resource. So in this case, a lot of these are in apps v1, that's GA, and then also jobs are in batch v1. The one cron job is still in v1 beta 1, and that just means that it's in beta, and we're working towards making that GA, and eventually it will be in batch v1. So future directions, I kind of touched on the cron job to GA. That's still being worked on. There's still some bugs tying out there. Some of the things that we worked on, the TTL controller for jobs garbage collection. So this allows you to specify a time to live for certain resources. Right now, I think it only works with jobs, and it's alpha in 1.12. But effectively, it will allow you to garbage collect resources that after some amount of time. Then there's the daemon set is shifting to use the default scheduler. So historically, the daemon set basically takes care of scheduling pod itself, which means it can't take advantage of some of the things that the default scheduler has, and it has its own kind of separate code base for that. So switching to the default scheduler is going to make reuse a lot easier there. And that's beta in 1.12. Optional service environment variables. So this is a flag that you can specify in the pod spec to disable the environment variables, the default environment variables, so the Docker link environment variables that show up. And that's going to be available, or is available now, I guess, in 1.13. And then there's also this provisional proposal going on right now on sidecar containers, and this is about managing the life cycle and dependencies of containers within a pod. So you can mark certain containers as sidecars, and then the scheduler will the controller will make sure that the pods that are marked as sidecars will start up before the main pods, the main containers, and then when tearing down, the sidecar containers will be the last to be shut down. So this is useful if you need to set up proxies or things like that before running the main containers in the pod. Startup. So the first containers to start up in the pod will be the sidecar containers.
I have a question about that.
Yes.
Generally, but if you want to hold it till the end.
No, feel free.
Okay. So one of the things that I saw in a presentation recently was an enterprise where they said, okay, there are so many cool tools out there for things like tracing and service meshing and observability, and so we just threw them all in our cluster, and then it turned out they all create sidecars in all our pods, and something like 2/3 of the work getting done in that cluster was actually just sidecars. So they ended up having to go back and do okay, which of these do we really need? And I think that makes me wonder if there's any possibility of some sort of limit on how much resources sidecar containers can consume in aggregate before you throw up a flag and say, hey, you're hitting the limit here.
Yeah, it's an interesting idea. So having kind of a global limit on sidecar resources, or like separate limits on sidecar containers.
Yeah, exactly. And be able to say, hey, this pod is doing X amount of work, but 80% of it is just the sidecar containers constantly doing stuff. You don't need that pod.
Yeah. Yeah, and at that point you might want to consider moving away from sidecar containers, just having pods somewhere else that interact with that service. Yeah. Yeah. No, that's interesting. A potential cap, maybe. A potential enhancement proposal, yeah. So going out of core here and talking about some of the other things in the ecosystem. So obviously, I'm sure many of you have heard of Helm. Helm is no longer part of SIG Apps. I think it was still 6 months ago. It was fairly recent. The Helm has now moved to a top-level project under the CNCF. They have separate meetings every Thursday. I think at 9:30 a.m. PST. Yeah. Oh, Matt Fisher's there. You can talk about Helm. And 2.12.0, you would have just heard in the keynote, has been released as well. Helm has its own set of sub-projects. One of them is Charts. And Charts itself has an hour meeting every other Tuesday. And in the Charts team, we just launched the Helm Hub, which again, would have just been announced in the keynote. Which is, so one of the issues with Charts was that there was this huge repository inside the Helm org, which would have all the charts in both stable and incubator. And there was this huge bottleneck in kind of getting charts merged into there. And so we're trying to switch to a more distributed model where maintainers are responsible for their own chart repositories, but there's still one place where people can go and discover and find charts from different repositories. So that's the idea with the launch of the Helm Hub. And we think it'll be a lot easier for people to go and find what they need, but for chart maintainers not to be kind of pushed back by this bottleneck or held back by this bottleneck of trying to get things, updates and new charts into stable. Yes. That's the current plan. There isn't. I don't think there's anything. I think so. The plan is to post the launch of the Helm Hub to work on documentation and to make it easier to run up your own chart repositories, because that's one of the biggest hurdles of this, is that the stable repository is easy. I can just send a PR and I know it's going to appear in that repository. How do you go and stand up your own chart repository is a different problem. So we'll have some documentation on improving that. And then once we have that, we can start motivating chart maintainers to move their charts into their own repositories. So definitely check out the Helm Hub. And then Chart Museum, again, I'm kind of just reiterating what was said in the keynote, I think, but the 0.8.0 was released there. And in Cube Apps, which is another project, which is an application dashboard that makes it easier to install Helm charts in your cluster, just released 1.0. Other things we worked on documentation-wise, we came up with a set of guidelines around what labels should be used within your resources to help group those resources and make it easier to find what's running in your cluster. So here's an example of a case where you might have a WordPress application that includes a database, so like MySQL, and the resources, the deployments for MySQL, or the stateful set for MySQL would have a label saying app.kubernetes.io/name MySQL, but it would also have this label part of that would say that it's part of the WordPress bundle of resources. And that just makes it easier to kind of group those resources and find them in an easier way. And we're seeing more and more applications adopt this label structure. Right now, it's just a convention. I think ideally, in the future, it'd be good to see some tools adopting this and kind of making this easier, so you don't have to do anything, it just happens. So Helm could be a good oh. They're still using the old label. Oh, sweet. Oh, perfect. Okay, yeah. No, so some tooling is definitely starting to adopt this, which is good. Yes, this is part of the Kubernetes documentation. So maybe we can go and find it. Can just do a search. Here we go. Yeah, so you can just do a search. You can probably search that in Google as well. That will come up. So this was done as part of a working group that spanned a couple of different people, and I think a few different SIGs as well. Obviously, SIG Apps was a big part of it, and I think it was actually the first working group to close as well. So it was the app definition working group. This was the output of it, and it was good. It's good success. We actually closed the working group.
The existing franchise of this one, is there a plan to consolidate?
To move towards this set of labels? Yeah, so right now, the labels are still using the kind of older set of labels that the charts used. And I think the plan is to try and migrate chart authors to upgrade to these new set of labels. That would be a breaking change because some people might be relying on those older labels. And also it will change the way deployments will reference, because I think some of those labels are used to actually reference like the pods that a deployment is part of and things like that, the selectors. So that might be a breaking change, but hopefully we can slowly migrate onto that. I think a few charts in stable are using these new labels, so it's just been a slow rollout. So I briefly mentioned the application CRD and controller. And the idea of this project is basically to define a common API to understand what an application is within Kubernetes. And I should make clear here that the application CRD is not going to be responsible for deploying applications. It's more just to give a representation of what applications are installed in the cluster. So it's kind of metadata plus the controller is going to be responsible for gathering kind of aggregated health metrics about the application, and also manage garbage collection. So when the application kind gets deleted for that particular app or application instance, the garbage collector will go and clean up all the other resources. But it won't be responsible for actually deploying those applications in the first place. That would still be delegated to tools like Helm or kubectl itself, or JSONet or KSONet or whatever you want to use. But the idea is that this will then allow like a cluster operator to run something like kubectl get applications and see what applications are running in the cluster without having to worry about what application or what tool was used to deploy that application. So I could use KSONet and I could use Helm, and I'd still be able to do kubectl get applications and see both of those applications running in that cluster. And then that also opens up the possibility for UI tools like the Kubernetes dashboard or Kube Apps to then go and list those applications and show them in a nice UI format. So that's still kind of a work in progress. Obviously, contributions and opinions are very welcome there. Here's the repository. You first, and then. So the CRD, and I can go to the repository real quickly. The CRD has a bit more information that the labels don't really cover, and I think both kind of can be used together to gather information about what's going on. But to give an example, okay, yeah. Well, just to give an example, I think like some of the things that can't be really represented in labels, things like icons, which would be like a kind of a base64 encoded icon string, and then there's a few other things like being able to check the status of the application as a whole, a health check, which is something that the controller will be responsible for. That's something that wouldn't be as easy with just labels. So that's kind of some of the ideas around it.
How does this compare with the application controllers and operators?
So the main thing here is that the application kind is not responsible for actually managing the application. It's more just metadata. So it wouldn't do any sort of operation at all. But for example, the etcd operator could also deploy an application instance resource for you to know that there's an etcd cluster running inside this environment that's been created by the etcd operator. So the etcd operator will still do the deployment and the management of that cluster, but you'd be able to get information about it using the application resource. So basically, the operators could interrupt with the application kind.
This also cover, seeing some parts conflicting with service catalog, services.
Mm-hmm.
Service catalog would like to be part of applications. So will this cover both parts and
That's a good question. I don't think that the service catalog has been discussed in the scope of the application CRD yet. But you can go over to this repository, and I think that'd be a great question to ask there, because I think that's a good point. It'd be interesting to see what applications are connecting to what services from the service catalog, and I think that could be an extra field in the spec to denote that. So yeah, I think if you go to this repository and create an issue there, or if you just come on one of the calls and ask that question, I think that'd be great. And actually, speaking of the service catalog, that's a great segue to the portable service definitions, which is another proposal that's in progress. And the idea of the portable service definitions is essentially to create a common API for requesting and consuming external services like MySQL. And the main way this differs from the service catalog is that this is more about making sure the way you request an external service and consume it in Kubernetes is portable. So whilst the service catalog could be a backend for actually going and provisioning that external service, there's currently no way to ensure that the credentials that we're going to get back into the secret that Service Catalog creates for you are going to be portable between different cloud platforms. So the Azure broker has the Azure for MySQL, and that'll get me a set of credentials in the secret, and then the Google broker has the Google Cloud SQL, which will give me another secret, but those credentials aren't going to necessarily map to the same thing, and that means I can't write one deployment manifest that is able to read in those keys in a portable way. So with portable service definitions, we're going to come up with a spec for particular services, because you need to have that knowledge about a particular service to be able to understand what keys make sense and what that format should look like. And the idea is to create kinds for each of those services so that people can request them in a common way. And the service catalog could indeed be a backend for those definitions. So when I request the MySQL resource, that actually triggers the service catalog to go and provision that, and then map the credentials back to the format that the portable service definitions expects.
Kind of like cloud events, like the cloud events thing was about democratizing the events that were coming in and out of different event systems, like Prometheus and Google and all that, and bringing it into Kubernetes.
Yeah, it's kind of similar to that. It can also be kind of similar to, I guess, persistent volume claims and storage classes and that idea, right? So like you don't have to know what's actually going and provisioning that, but you care about the interface that you're then connecting to with your applications. So I see it at kind of that level, but also the cloud events abstraction makes sense as well there. Yeah. But again, this is a KEP that just got merged. If you haven't seen the new enhancements repository, it's just Kubernetes enhancements. And under KEP SIG Apps, you'll find all the enhancements proposals for SIG Apps, and the portable service definitions is here. So if you have comments or feedback on that, this would be the place that you can go and send a PR to. So SIG Apps is interesting in that it's not just about what we do in core or the code that we own. Again, as I mentioned briefly at the start, we really care about what tools people are developing in the ecosystem to solve the problems that developers and operators have. And so there's a bunch of other ecosystem projects that are really great, and I'm probably missing a lot more. And if I'm missing yours, I'm sorry. There's only so much space a PowerPoint presentation can have. But yeah, we just love all of the great tools that have been created in the ecosystem. We love to talk about them. If you're working on something that is related to SIG Apps, please come and demo it. We'd love to see it. We'd love to help you get more feedback and help you drive the features that you need to develop it. And once again, if you want to get involved, SIG Apps Deep Dive is Thursday at 11:40 a.m. So I'll be there, Matt Farina will be there, a bunch of us SIG Apps veterans will definitely be there, so you can come and ask those questions and just get involved. Outside of KubeCon, when you all go back home, we'll be skipping next Monday's meeting because we'll be kind of recovering from from KubeCon, I'm sure. But the Monday after that, actually, no, we'll be starting up again in January because we'll be hitting Christmas and New Year's. So I think the next meeting will be sometime in January. I think the first Monday in January. I think it might be the 3rd. And then if you can't make it to any of those, there's always the Slack channel, which is open for everyone to use, and just go and if you have any questions there, it's a great place to go and ask and ping people. And also the mailing list if email is more to your favor. Thanks a lot. I'll leave the slide up in case anyone wants to find out more. Yes. The benefits of using the application CRD. So if you as a cluster operator or application operator want to get an overview of what's running inside your cluster, then the application kind gives you that ability, and you can also see kind of at a glance the health of each application. So it's kind of this abstract view of what applications are running in your cluster. That's the idea. Sorry, did that? Right now you'd have to do that, or you include the application kind as part of your application. In the future, we'd like to see tools actually adopt the kind itself and actually generate it for you and deploy it for you. So right now it is a little painful, but the idea, I think Helm and Helm freed its proposal to adopt the application kind.
I think the idea is once the application kind either something that the community agrees with and forward,
Mm-hmm.
that's something that we want to have in packages applications, that we can have an opportunity to do that, and we can treat it as any other resources, template, filter, and stuff.
Yeah. Yes.
Yeah, so it sounds like the application is meant as a kind of a singleton for a given kind of app. And what about the notion of different use cases or label instantiations or subsets of serving tend to work around that?
So the application kind will be the API, but then each application running in your cluster will be an instance of that application kind. So within that, there could be labels that differentiate kind of different roles that like, so you have the same WordPress application, but one has a different name or a different label to say what kind of I don't know, tier and then also there'll be Kubernetes namespaces involved as well. So there's different levels at which we can kind of isolate that metadata. Yes.
Just wanted to point out that I advertised you and indicating the application resource as a schedule point and attaching the policies, telemetries, right? Modeling graph shows application traffic and defining quotas.
Yeah, definitely. I think that would definitely be a great use case for it. Being able to understand and telemetrize like what's actually running in your cluster is really that's good to hear, and it'd be good if you have something that's demoable there. That would be great to have you on, or maybe just discuss what you. I don't want to put you on the spot, but like sounds good. But yeah, it'd be great to see, to at least start hearing about what people are thinking around it, and because that's really at the stage we're at. We just want to get feedback and try to understand a bit more what problems this could solve. I think we have a good understanding of what problems it could solve right now, but it's stuff like that we haven't heard of that it can also solve. So yeah, for sure. There was another question on this side. Yep. Yeah, exactly. That's a good point. I can't remember if there was some discussion around whether it should be set as the owner or if it should. Actually, yes. So I think the controller would pick up and use a selector based on the label and then set it as an owner for each of those resources. I think that was the plan. So yes, in that case, we get the Kubernetes garbage collection out of the box when that kind gets deleted. Yep. Yes. Can you elaborate on that a little bit?
For example, on knative, there is
Okay. Yeah, actually, I think that's a good point. I think if I remember correctly, the component kinds list that it takes is basically just an array of group kinds. So you could really point to any CID or any core object. Yes.
Is the idea that eventually we will deploy at the application level, so rather than deployment now or the Helm chart, like you're going to deploy an application and understand different buckets to deploy stuff?
No. So it'd kind of be the other way around. So Helm or kubectl would actually go and deploy the application for you. That's the idea. Right now, again, you'd have to go and create the application kind manually, but Helm create could go and spec out the application kind for you, so that you don't have, so you would include it as part of your deployment. We might be running out a bit of time here, but yes. So the question was, how does it differ? How does the application kind differ with operators and KubeBuilder? Or yeah. So when you're building an operator with KubeBuilder, you could have, so KubeBuilder could also spec out the application kind for you, or your operator, whenever there's an instance of the kind of your operator in play, then the operator could also go and create the application kind for you. So you have this other place where you can get metadata about the application. So they kind of interrupt with each other. I think it'd be interesting to see where that goes. But the application operator itself, or the application controller itself, would not be the operator. It would just be the metadata on the side of it. Yes. So I think that would still be the concern of the deployment tool. So if I understand the question correctly, it was about deployments and kind of doing kind of rollouts based on. Yeah. Yeah. So I think that would still be the concern of the tool that's being used to deploy the application. So either kubectl or Helm or kubeconfig or KSonnet, some of these tools, because they will actually be doing the rollout and deployment of those things. But then the application kind would link to all of those resources, and then you'd be able to see an aggregated health status about that while that rollout is going on. If that makes sense. I think we're slowly creeping into the next talk, so I will quickly get off. Thanks a lot for coming.